Hello, what's up, guys? This Crux Academy, this tutorial series is on a subject of fundamental of electric circuit. Beginning with this very episode as an introduction and some theoretical concepts, we'll try to cover the subject lessons by lessons in chapters by chapters by solving different problems and learning different theoretical concepts by the will of Almighty. Now let's dive into the first chapter. The first chapter is dealing with the basic concepts like charges, electric current, voltage, power, and so on. So, beginning with the charge, this is an electrical property of the atomic particles, the subatomic particles like electrons, protons. They have these basic properties, built-in properties, like as a mass, as protons and electrons have a mass, they also have these charges as their built-in properties. The charge of the particles is measured in coulombs. So an electrons have 1.6 times 10 raised to minus 19 coulombs, and the proton have the positive of the electron, having the same charge, the same amount of charge, but different polarities. The unique properties of charges that they flow, the fact that they are mobile, the fact that it's mobile, it can be transferred from one place to another just by carrying energy, so that energy can be converted into some other forms of energy like kinetic energy and some other potential forms of energies. That flow of charge is known by current. This electric current is the time rate of change of charge, which is measured in ampere. It is like the rate of change of the charge. It's given by dq in, it's given by dq in dt, as you see right here. So it is the rate, it is the change, mathematically explained. Change, or the rate of change, is mathematically explained through derivatives. Okay, we have charge, the charge transfer between time to time t is obtained from the previous equation of current. We mentioned that I is equal to the current dq over dt. So by crisscrossing this equation dqi dt and integrating from initial time t to the given time, we will get the amount of charge that flowed through the medium or the conducting body. So now let's come to the voltage. By the way, we will solve some practical problems regarding these equations and these concepts as a whole. Voltage or a potential difference is the amount of or the energy required to move a unit charge through an element or through a conducting body. In order to move a unit charge or a bunch of charges, we need a potential difference or a battery or a generator. So that is given by, mathematically explained as dw, or the work done, dw is the work done, over dq, the charge, the work done in terms of the charge, the derivative of the work done in terms of charge. So VAB is equal to minus VBA, or the potential difference to move a charge from point A to B is the negative of the potential difference or the voltage to move a charge from point B to A. Next, power. So let's come to the power. So power is simply the time rate of expending energy. the rate of doing work from the elementary physics, as we know from the elementary physics. So it's measured in what the power is mathematically given or explained, d work done over dt, the work done to move a charge, or the work done to move a charge over dt, or the derivative of the work done, the rate is given by the rate, So multiplying the numerator in the denominator by dq would give us dw over dq dot dq over dt. So this is, we know this from the previous equation, that it's a voltage, and dq over dt is the current. So P is equal to V times I. This equation is simply derived from this one. So power is, the summation of power is 0. Summation of power is 0. That means the power absorbed is equal to the power supplied. The total power in the system is conserved. So the amount of power supplied is equal to the amount of power absorbed or dissipated on the loads. So the other concept is the passive sign convention. The passive sign convention. The passive sign convention is explained as, when the current is entered through the positive terminal of the element into the negative terminal, the power would be positive. The power is absorbed. Whereas when the current is entered into the circuit from the negative terminal of the element, the power is negative. That element is a power supplier, or power is supplied by that element. That may be a source, most of the time voltage source, or would be a current source. So having seen this, guys, we're gonna solve problems in the next session. Thank you.